Welcome to the knowledge series. Here, under the course Easy 407 Computer Communication, we will be discussing on security at transport layer. As you know, under the TCP/IP protocol, transport layer appears at the third level from the bottom. So, the transport layer security is basically designed to provide security at the transport layer itself. Network security entails securing the data attack that is being basically observed under the networks. To achieve the network security, there are different protocols is being followed, such as SMIME, SSL, TLS, SSH, and IP securities. So here the two protocols are prominent in the current scenario for providing a security at the transport layer. The one is the secure socket layer protocol, another is transport layer securities. So you can see in this particular slide the physical network, IP network, TCP protocols and applications. So under this TCP, this SSL and TLS is basically resides, and that is being used for the providing a security towards the transport layer. Now we see the needs of the TLS. If you see here, the transport layer security schemes, it address towards the confidentiality and authentication problem. Confidentiality means we try to do a public at the sender side and the private at the receiver side. Authentications means private at the sender side and public at the receiver side. By exchanging a TCP/IP protocols based on the network communications. TCP/IP is a connection-oriented protocols. That's why these such communications where the confidentiality, data integrity, server authentications, and client authentications, all these things coming together is being addressed under this particular point of the transport layer TLS. Another is the security at this layer is mostly used for the HTTP based web transactions. So wherever you are using HTTP web transactions, this protocol is also coming under the pictures. So that is what we see is that the need of a TLS. If you look across the philosophy of a TLS design, under the application, the TCP is coming. So in the TLS protocol, it operates on above the TCP layers. That means this is your TCP, physical network IP TCP. Just above the TCP, this transport layer security is coming. So you can see this one at this particular point. So here the TLS is a separate entity. We can if you enlarge this one under the API sockets, so you can see here it comes as API means application program interface socket. So this complete is nothing but a TLS protocols. So design of these protocols are popular in the APIs to TCPs called as a socket. Socket, we are using a socket. Socket is equal to IP address plus port number. So that is known as a socket, it means, and that is used for interfacing application layer to TCP layer. So you should remember that TCP is this TLS is basically a socket, a protocol space related to the socket, and that based act as an interface between the application and TCP layer. Now what exactly this socket and what is this port? Let us understand this one. Now here is a socket is being shown. See, on a socket is shown for the TCP IP port. This is your TCP IP port. Client is on one side, server is on one side. With the IP address of the client is IP1, server address IP is nothing but IP2. There is a common port is the port 25. There is a port 5000 is for client, and there is a port 80 is for a web server with respect to the server. Now actually IP address, what exactly the IP address? IP address is basically used to identify the computers. And now to identify the computers, only the IP address is not sufficient, because a computer can run for a multiple application, and for a multiple applications you cannot use for a multiple IPs. But apart from the IP address, there is some terminological termed as a network port that used to identify an applications or the service that is running on a computer. That means IP address is only to identify the systems, what is located, say mobile system, computer system, laptop systems, like that. The number of devices that is connected to the internet world is having its own IP. But applications, there are vast number of applications running on this one. Those applications, if you want to associate, you need that network to identify through the port. So the network port identifies the application or the service that is running on a computer. So you have to identify the distinguish between IP address and port. IP address is for identifying the systems. Port is for identifying the for the computers. So that's how you should do it. I repeat again. When we talk about IP address is basically used to identify the systems. So identify the systems, that is very important. And when you talk about a port, you have to understand that it identifies the applications. So because various applications that is running on a systems or various services that is being running on a your mobiles or on a computers, all these things is playing a separate separate way of identifications. So the use of a port will allow the computer or a device to run multiple services or a application that I have just now shared. So if you try to understand the analogy, assume that you have a house or an apartment. So automatically your house will be having a separate address. So that no, your apartment will be having, or the house will be having a separate address. So that it is just like IP address corresponding to a street address. Now if you take an apartment itself, every apartment share the same address. However, each apartment will have its another unique number, that is what we termed as a port number. So IP address is a external, port number is a internal. That way also you can able to assume. Now coming to the socket, when you use a word socket, it is a combination of a IP address and the port address. So that you have to keep it in your mind. Socket, the word, once you understand, the socket is equal to your IP address and plus your port number. This you have to keep it in your mind. This is very important components. That is what we see here in this case. Now coming to the term with respect to the socket, I have already stated. Now let us see what the socket is actually means. Still, assume that you are looking for a Google website, and at the same time you are looking for a Yahoo website also, two different websites. So in that case, your PC will have its own IP. Okay, so IP1, let us take IP1 here, it is fixed. Now you need a port. Let us take you take one port, say 60,000. 60,000. Assume one. I am giving one random value, 60,000, and that 60,000 you have used for identifying with respect to the what is that port number. So IP1 plus port number, what is that? It is going to be a socket. Okay, so that is the socket with respect to yours. Assume that you are searching for a Google, so it has to do a communications with respect to your server. That means your client and server are interlinked. So thereby it will try to search for that particular Google page through the IP2 address which is there for the Google through the port 80, because port 80 is the web server. So it will go as IP2 plus 80 will be automatically giving the way out to the internet world. That means IP1 plus your say 60,000 is your port number, or let us take a 60,000 phone number, or if you are let us take 100 is a port number. IP1 plus 100, and here it comes IP2 plus 80. It will go to the internet world and look for the Google server. Now assume that you are looking for a Yahoo. Okay, Yahoo. So in that case, IP1 plus your port, and you are going for another Yahoo site. Let us take that the Yahoo site with respect to you have a IP3 is the site related to the IP3 of the Yahoo. IP3 plus the port 80. So automatically it will go because this is a standard port. It will take a destination socket of the Yahoo server. So what is the Google server socket? It is IP2 plus port 80. And what is the Yahoo server socket? IP3 plus port 80. So that is how you identify the socket. And what is the socket of Yahoo Google client? It is nothing but IP1 plus, say if you are taking 100. If it is a Yahoo, say IP1 plus say 110. So that is how you can identify the IP1. So port number is nothing but your internal home address and apartment address, like that you can assume. So that is what means a socket. Socket is something like you have address and a door. So when you have address and door, that becomes a socket. So that is what address plus port number. So if you look across a port number is classified as a well-known port, registered port, and a ephemeral port. Ephemeral port ranges between 49152 to 65,535. Registered port is 1024 to 409131, and well-known port is 0 to 123. So that's how the port is being classified. So based on the port, it is being used for the different purpose. So that is how when you talk about this particular port, this is a well-known port. Actually these are allotted to the server services by the internet assigned network authorities. And for example, a web server, normally we call termed it as a port 80, or SMTP server, simple mail transfer protocols, is nothing but port 25. So these are nothing but your port address which is coming under the well-known ports. Port number 1024 to 49,151, which is a registered port. This type of port is being used for the service with IANA. That is how this registered port is being assigned. Now the third type of a port 49,000 to 65,000. This is another type of a ephemeral ports, and this is when a web browser is to connect to the web server, or like a client, you want to use a particular client program for the access of your some of the site which you have personally designed for the web server applications, or when or you want to use the web server through your browser. So those are nothing coming under this particular ephemeral ports. So like that, the port number is being defined. So these are the several internal houses are there which is using a different application. In your building, different people are staying in a different apartment. So like that, the port is also having a different activities, different apps that is running under this class. Now coming to the next of our discussions is with respect to the SSL. So SSL stands for a secure socket protocols. That is what we see, and a secure SSL is a secure protocol, and it is developed for sending information security over the internet. And this is basically designed to provide a security and a compression service of a data that is being generated from the application layer. So that is SSL is basically used to receive data from an application layer such as a HTTP, and this data is being received from that application layer and is being compressed, signed and encrypted. Now the speciality of this SSL layer is that if you have noticed that if there is a in the web address like HTTP :/ and HTTP yes :/ these two differences, the HTTP yes HTTP yes and HTTP only. The yes is indicating the secure. So the secure socket protocols that supports the website with an authenticity is nothing that is HTTPS is based on the secure protocol socket layer protocols, and many website uses this SSL for a secure area of the of their sites. That is how the site is being finding more secure. And here the earlier the SSL was limited to only 40-bit encryptions, but nowadays it has gone up to 128-bit encryptions or even higher side. So that is what we try to see. So this is SSL is actually encrypt the data so that a third party will not able to eavesdrop. That means it will not able to find the access of to the site. Now coming to the salient feature of the SSL, if you try to see, it provides network connections through a security through security. So first is confidentiality. Confidentiality means what? That means informations is not is exchanged in an encrypted forms. So when you encrypt any information, so then that means you are creating a confidentiality, and in the case of authentications, communication communication entities identify each other by using a digital certificates, because you use a private key to create a digital certificate. So a web server authentications is mandatory where you are using a client authentications. Reliability means it try to check the message integrity, that is it is not being modified. And this SSL is typically works under the TCP applications, and it is supporting all the web browser security, so that there will not be any leakage of the informations under the web server under the case of use of the website. From the website, the data will not be modified, or it will not be it will not have a break of confidentiality and other issues. So the primary aim of SSL is to develop a web supports. Now if you look across the architecture of the web SSL, you can see that it is between the application and the TCP. Normally in the TCP IP, this SSL is not shown, but actually SSL is specified to TCP, and it gives the interface supports or secure support between the application and the TCP. Now actually SSL only supports the TCP, but it does not work with the UDP. So that's why it provides an application programming interface to the TCP using a SSL. And as I have mentioned, that is SSL protocol is designed to interwork with the application layer and the transport layer. So SSL is not a single layer protocols, and it has several sublayers also. So that is what you should keep it in your mind, that it will be having more than one layer. So to understand this SSL further, you have to see the SSL protocols. Once you see the SSL protocols, it has a SSL handshake area, it has a SSL client change protocol, SSL alert protocols, application protocols, SSL record protocols, TCP, IP, like that. SSL is basically divided in these fashions. So one side you can see that it is a collections of handshake, chain cipher, alert protocols, applications, and record protocol, then work under the TCP IP scenario. In the handshake, when you talk about a handshake protocol, it is very complex in the case of SSL, because it tries to invoke applications data that is transmitted from the between the client and the server. So that establishment of the sessions, such as you can take it as authentications or negotiations of the key, establishment of a key, all these thing is coming under the handshake protocols. Next is the chain cipher protocols. Chain cipher protocols is basically, it comprises of a communications entities between the client and the server, so that a message can be exchanged between the parties using a encrypted form of informations, so that the integrity can be maintained. Alert protocol is basically, it tries to see that is there any error in the message. See if there is a bad message or a bad informations that has been recorded based on the exchange of the informations under the TCP conditions, then there will be an alert message will be there, and that alert message will notifying whether this particular protocols has received a bad or an unknown certificate notifications, like form of a security parameters. So that's how this particular protocols try to see, and it works for the different applications protocols. If it is HTTP, so it will provide this protocol support, and it become HTTP. Yes, and this I have mentioned that about the recording of the SSL record protocols, TCP IP scenarios. So these are the class related to the SSL protocols. And now we see the next is the transport layer security. Now, what exactly the transport layer security? Transport layer as security we will we consider, because this is a protocol that provide a communication security between the client and server. So if you take a client and server, this communications that security is handled by the transport layer securities. And here it tries to enable the privacy, integrity and protection of the data in this particular protocols. And TLS, transport layer security, is a successor of the SSL. Just like we talked about the SSL, so transport layer is another form of security which is actually the successor of SSL. Now, as per the IET, it released the TLS way back in the year 1999. And the TLS primary duty is to ensure the web browsing security, application access security, data transfer security, internet security, and like that several security it tries to handle. And it has two different layers. One is TLS handshake protocol and another is TLS record protocol. So that like that one, two protocols is there. One is handshake protocol and record protocol. Handshake protocol is nothing but how the client and server try to do a handshaking, and these are nothing based on the encrypted form of informations, and thereby the data what is being sent is encrypted data. TLS record protocols, it is actually it works on the top of the TCP protocol, and it tries to see that a proper, secure and a reliable connectivity can be maintained, and thereby it will enable to provide a data encapsulations and a data encryption services. Now let's see some of the salient features of the TLS. TLS here protocols has the same objective as a SSL. That is one. It enable the client server application to communicate in a secure manner. So what will happen then? Authentications can be maintained. It can prevent use dropping. It can resist the message modification, so the integrity can be maintained. Another is that TCP protocols site is based on the reliable connection oriented protocol, so that is one of the plus point. The next is that the architecture of a TLS is similar to the SSL v3, that is your service socket layer protocol. So that is how or secure socket layer protocols, that's how it supports. Next is that though SSL v3 and TLS protocols are similar, however there are several changes that is made on the architecture and functioning for the handshaking protocols. So that is what we try to see about the salient features of these protocols. Now let's see the working of this TLS. Now TLS connects to the server using a TCP. The client will be interacting with the server, and for that one is that it will follow that either SSL or a TLS. Here we will be using a TLS protocols, and it will be using a cipher suite compression method for this communications. So here you can see that TLS is here above the TCP, and this one it supports the protocols and a record. That is what we have seen. It talks about the protocol and record. In the protocol is that applications, alert, chain cipher, spec and handshake. This chain cipher, specs and handshake is nothing but the things you have seen in the SSL. And what is record? Fragmentation, integrity, authentication, encryptions. These are the records, or these are the you can say that you can put like these are nothing but the future inbuilt in the TLS, and these are nothing but the functional activities that supports by the TLS for the applications, alert, chain ciphers, and handshaking scenario. Now we go further with respect to the comparisons of a TLS and SSL. Now let's see the key areas. Full form. SSL stands for Secure Socket Layer. TLS stands for Transport Layer Security. Coming to the next key, it is about the algorithm. Forteza algorithm. The Forteza algorithm is supported by SSL. Forteza algorithm is not supported by the TLS. Version of the SSL is 3.0. The current TLS SSL is 3.0 and the TLS is 1.0. Master secret codes. SSL managers uses a message digest to create a master secret codes, and SSL uses a pseudo random functions to create a master secret codes. Authentication. SSL uses a message authentication code protocols, and here TLS uses a hashed message authentications code protocols. So one side it is a SSL that uses a message authentication code protocol. Here TLS uses a hashed message authentications protocols. Complexity. SSL is complex than TLS, and TLS is simple to implement. So that is how you find the difference. So when we talk about the working of the TLS, automatically we find that TLS is easy to operate, and in the case of a TLS, first of all the server will check how the TLS supports the clients and the server, whether it is using encryptions and compressions. And after the basic setup, then the server will provide the certificate, and that certificate must be trusted for the clients. That is the second is that, and once the certificate is verified, once the certificate is being verified, then the key exchange will take place, and by using a public key, that is your pre-masters, it will create it will try to create the confidentialities, and both the server and the client will support with the a symmetric key encryptions, and thereby the handshake will take place between the two host parties, and finally the authentications will be able to maintain. Thereby the TCP connections for the both side will check for the proper connections and as well as for the terminations. So server side verifications, public certificate distributions. Third is your client server symmetric key encryptions and the handshaking between them, and finally based on the based on the connectivity and exchange, it will be able to terminate. So this is what we see in the case of a working of the TLS. That's why you find it is simpler as compared to the SSL. So with this we come to the point of our discussions end with respect to the discussion that we had under the transport layer protocols, the discussion on SSL, TLS and its comparisons. Thank you.